So in this video, we're going to talk about how to use quadratic functions to model data in Desmos. So remember, we can use the quadratic formula to solve any quadratic equation as long as it's in standard form. Remember that in standard form, our quadratic equation is set equal to 0. So when you use a quadratic formula to solve ax squared plus bx plus c equals 0, you always want to start off by identifying the values of a, b, and c after you set the equation equal to 0. Then you're going to plug these values directly into the formula and simplify. Remember that the plus or minus in the equation gives you two solutions for x. So for example, let's try solving 6 equals x squared minus 0.5x minus 8. So notice this equation is not already set equal to 0, so I'm going to start off by subtracting 6 from both sides. So when I do that, I get 0 equals x squared minus 0.5x, and then minus 8 minus 6 gives me negative 14. So I have minus 14. So here's my value of a, here's my value of b, and here's my value of c. Remember, if there's no number in front of x squared, there's basically a 1 there. So I have a equals 1, b equals negative 0.5, and c equals negative 14. So if I plug into the quadratic formula, I have negative b, so negative 0.5, plus or minus the square root of negative 0.5 squared minus 4 times 1 times negative 14. And that's all going to be divided by 2 times a. So here the negative 0.5 is going to give me 0.5. So I have 0.5 plus or minus the square root of. And what I'm going to do is I'm just going to type everything under that square root into my calculator and just simplify it all at once. So I'm going to do negative 0.5 and then square that minus 4 times 1 times negative 14. So when I do that, that is 56.25. So I have 0.5 plus or minus 56.25, and that's divided by 2. So now if I do the square root of 56.25, I have 0.5 plus or minus. So let's do that second square root and then 56.25. That is 7.5. So I have 0.5 plus or minus 7.5 over 2. So remember, the plus or minus gives me two solutions. If I do 0.5 plus 7.5, that is 8, and then 8 divided by 2 is 4. And then if I do 0.5 minus 7.5, and then hit enter, and then divide by 2, that gives me negative 3.5. Okay, so that's how you get the two solutions to this quadratic equation. So sometimes the data that we look at in a scatter plot may have a curved pattern. So in these cases, you'll have to use a quadratic regression to write an equation that best models the data. So let's look at the instructions for how to do quadratic regressions in Desmos. So to do this, you're going to click the plus sign in the upper left-hand corner and choose Table. So let's write a quadratic equation to model this data given here. So now you're going to enter the data into the table, so the x values and the y values. Notice that Desmos tries to kind of predict the next value. If their prediction is inaccurate, just keep typing and it's fine. It'll just overwrite it. Okay, so now that I have all these values entered, I need to tell Desmos that I'm looking for a quadratic function. So I'm going to type y1 is approximately ax1 squared plus bx1 plus c, right? I have to enter the quadratic equation in standard form. So now what it does is it gives me values of a, b, and c that I can use to write my equation. So I get the equation 1.21x squared plus 13x plus 504.26. Okay, so that's the quadratic equation that models this data set. So now let's look at this example. It says the equation negative 0.0002x squared plus 0.0334x minus 0.5033 models the average number of registered automobiles per licensed driver in the United States from 1950 to 2010, where x is the number of years since 1900. Use the equation to estimate the number of automobiles per licensed driver in 1987. So the key thing to notice here is that x is the number of years since 1900. So if we're talking about 1987, we're going to say, well, 1987, how many years after 1900 is that? And that is actually 87 years. So we're going to go to this equation and we're going to plug in 87 for x. So we have negative 0.0002 times 87 squared plus 0.0334 times 87 and then minus 0.5033. Okay, so I'm just going to enter this all into my calculator, just all on one line. So negative 0.0002 times 87 squared plus 0.0334 times 87 and then minus 0.5033. And then when we hit enter, we get 0.8887. Okay, so that means that there was about 0.9 automobiles per driver in 1987, right? A little bit less than one. Okay, so now here in this problem, we want to determine the equation of the quadratic regression curve and use the equation to estimate how long it would take a single person to complete the project. So we have the number of team members, so since that's the input, we're going to call that X, and the time to complete the project, we're going to call it Y. So now we're going to go to Desmos and we're going to do the quadratic regression. So whenever you're doing this in Desmos, I think it's very helpful to just click the X and clear anything you have from a previous problem, because otherwise it starts renumbering the variables and things, and that gets kind of confusing. Okay, so I'm going to pause the video and I'm going to let you go ahead and enter these values across the top into X, and these values in the second row are going to go into Y. Okay, so now that we have all these values entered, we're going to go ahead and go to row 2 and tell it to approximate a quadratic. So y1 is approximately ax1 squared plus bx1 plus c. Okay, so now we're going to scroll down to parameters, where will give us the coefficients of our variables. So we have y equals 0.122x squared minus 3.46x and then plus 28.34. Okay, so now what we need to do is we need to use this to estimate a specific value. So it wants us to figure out how long it would take one person to complete the project. So to figure out that, we're just going to plug in x equals 1, right? So that's for one person. So we do y equals 0.122 times 1 squared minus 3.46 times 1 plus 28.34. So I'm just going to go to my calculator now, and we do 0.122 times 1 squared is just 1, so you don't have to really do that if you already know that. Minus 3.46 times 1, and then plus 28.34. And that hit enter. So you can see that it says y is about 25. And so it's going to take them about, let's see, 25 hours to complete the project. Okay, so now you can go ahead and pause the video and try this example on your own. It says this is the estimated populations of Albania from 2006 to 2015. So the years after 2000 we're going to call our X values, and then the population we're going to call Y. So I'm going to pause the video while you go ahead and enter this into Desmos. Okay, so you can see now I've entered these values into Desmos, and I've told it to go ahead and estimate the quadratic equation. So this gives me the quadratic equation y equals 0.0018 x squared minus 0.0486x, and then plus 3.2189. Okay, so that's my quadratic equation. So it says now use the equation to estimate when the population had previously been 3.05 million. So we want to figure out what is x when the population is 3.05. So we have 3.05 equals 0.0018 x squared minus 0.0486x plus 3.2189. Remember, to solve a quadratic, we're going to need to set it equal to 0. So I'm going to go ahead and subtract 3.05 from both sides. So when I do that, I end up with 0 equals 0.0018x squared minus 0.0486x. And then plus, let's do 3.2189 minus 3.05. So that gives me 0.1689. Okay, so that is my quadratic equation. I'm just going to recopy it here. I have 0 equals 0.0018 x squared minus 0.0486x plus 0.1689. Okay, so remember, this is my value of A, this is my value of B, and this is my value of C. So if I go now to my quadratic equation, I have negative of negative 0.0486 plus or minus the square root of negative 0.0486 squared minus 4 times 0.0018 times 0.1689. Okay, and that's all over 2 times 0.0018. Okay, so now let's work on some simplifying. So I have 0.0486 because the two negatives cancel, plus or minus the square root. Okay, let's figure out what we have under the square root. So we have negative 0.0486 squared, and then minus 4 times 0.0018 times 0.1689. And if we hit enter, that tells us we have 0.00114588. Okay, and then that's all divided by 2 times 0.0018, which is 0.0036. Okay, so now let's take the square root of that. So we're going to take the square root of the value we have there. And that is the square root. So we have, this is going to become 0.0486 plus or minus 0.3385 all over 0.0036. Okay, so now we have two solutions because of the plus or minus. So let's figure out what those two solutions are. So we have 0.0486 plus 0.3385, 0.03385. Let's see, there should be a 0 there. And then divided by 0.0036. And so that gives me my first solution, which is 22.9. And now let's do the second solution, which we get when we subtract. So 0.0486 minus 0.03385, and then divide by 0.0036, and that gives us 4.1. Okay, so what do these numbers mean? Notice in the context of this problem, it is talking about how many years since 2006, right? So no, it's saying the number of years after 2000, okay? So what it is it's not telling us the exact values of the years, it's saying how many years it's been since 2000. So if we have 22.9, that is about 23 years since 2000, so that will be the year 2023. 4 is going to be the year 2004. Okay, so which is the correct answer that we're looking for? Well, notice that it's saying when had the population previously been 3.05 million? Okay, so if we look at this problem only goes up to 2015. So previous to 2015, it would be the year 2004, right? Because 2023 would come after that point. So we're going to say year 2004 is our correct answer because 2023 will come in the future. Okay, so using your calculator, you can model data using quadratic regressions, and then you can use these equations to predict future values.